Then it is now time to look at implicit differentiation. For a lot of students, implicit differentiation will be something new, so please note that it is important that you fully understand this thing. So implicit differentiation is a very important part of this part of the course, and I would advise you to go through this part of the course a couple of times until you fully understand what implicit differentiation is and how it works. So far we have always treated functions y, which could be written as f of x. So you have your outcome, which is an explicit formulation, an explicit equation in x only. For this kind of functions we saw the calculation rules, and so we can calculate the derivative easily. However, not all functions can be written in this form. Some functions are implicitly defined by a relationship between x and y. For this kind of functions, it will be impossible to write y on the one hand side of the equation and all x's on the other side. So, for example, think of the function x squared plus y squared equal to 25. This is very simple. A circle with a radius 5 and origin 0, 0. But we cannot convert this expression to an explicit expression. So we cannot write this as y equal some function f of x such that it is the same as the circle. So this is impossible. The best that we can do is y is either the positive or the negative root of 25 minus x squared. But so this is not one function, but two functions. An f of x, which might be the positive root, and a g of x, which is the negative root. Similarly, assume that we have x to the power 3 plus y to the power 3 equal to 6xy. Here also, it is impossible to convert this into an explicit expression. You can never write all y's on one side of the equation and all x's on the other side. Let us continue with the first example. So with the circle x squared plus y squared equal to 25. For this one, there are two ways to solve this. Either we solve it explicitly, and we do then this by different parts, so piece by piece, or we will solve it implicitly, which we will see afterwards. So if we want to solve this explicitly, what we will do is we'll solve it piece by piece. So an explicit solution is only possible if we can write the function as several subfunctions. So in this case, what we had was we had two subfunctions. So let's say we have f of x, which is the positive root of 25 minus x squared, and we had a second part, g of x, which was the negative root of 25 minus x squared. What we can see is that basically we split the circle in two halves. The function f of x are the positive roots, so this is the upper half of the circle. The function g of x are the negative roots, so this corresponds to the lower half of the circle. If we then want to calculate the derivative, we calculate it piece by piece. So we start with the derivative of f, so f prime. F prime of x is 1 divided by 2 times the root of 25 minus x squared times the derivative of the function inside the root. So the derivative of 25 minus x squared is minus 2x. So my derivative here is minus x divided by 25 minus x squared. The same way we can calculate the derivative of g, so g prime of x, and this will be x divided by the root of 25 minus x squared. So since we split the function into two subfunctions, our derivative will also consist out of two parts. One derivative for the upper half of the circle, one derivative for the lower half of the circle. The second way is to solve this derivative implicitly. So find an implicit solution. To find the implicit solution, we start from the equation. So we had x squared plus y squared is 25. In this case, it's very important to note that y is some function of x. So y is a function of x without explicitly defining the function. So y is f of x, but it means also that if we derive towards x, we also have to derive y. So this is very important. This is the most important step in the implicit differentiation. Understand or assume that y is a function of my variable x. What you then do is you differentiate the entire equation. So you differentiate the equations, you differentiate the left-hand side and the right-hand side, and you keep in mind that y depends on x. So we have the derivative of the left-hand side, so x squared plus y squared derived, is then equal to the derivative of 25. Then we work out this derivative. So here the derivative of a sum is a sum of derivative. So this is x squared derived plus y squared derived equal to 25 derived. Then the derivative of x squared is 2 times x plus the derivative of y squared. So y squared depends on x, so this derivative is not 0. So the derivative of a function to some power is 2 times the function times the derivative of the function. So this is basically just the chain rule that we apply. And then on the right hand side, we just derive a constant, so this is 0. The goal was to find the derivative of y, so to find the derivative of the function. So we have to bring everything that is y prime to one side of the equation. So this is 2 times y prime equal to minus 2 times x, or y prime is minus x divided by y. So we see that here we obtain an implicit notation, an implicit derivative, because my derivative is still written in function of y and not only in function of x. So it is a combination of x and y to have or to obtain the derivative of y. So we now have an implicit solution. Is this now the same solution as the one we found by solving it explicitly? And yes, of course, this is. So in the explicit solution, or the way to find the explicit solution, we had two subfunctions. Y is f of x, the positive root of 25 minus x squared, or y was equal to g of x, the negative root of 25 minus x squared. According to my implicit solution, here the derivative y prime is minus x divided by y. So this is minus x divided by the function f of x, which is the root of 25 minus x squared. And for the other one, y prime is minus x over y, which is minus x divided by the negative root, so it becomes plus x divided by the root of 25 minus x squared. And so we see we have identically the same solution as we obtained through the explicit solution method, which is logical, or which should be trivial, because basically we solve the same equation, so we need also to find the same solution. The second example that we defined at the beginning of this part of the course was x to the power 3 plus y to the power 3 equal to 6 times x times y. So this function is impossible to solve explicitly because you cannot write y as subfunctions. So it will be very difficult to find any subfunctions to describe this global function, this global equation in different parts. So the only way you have here is to solve it implicitly. And I would advise you to try to solve this yourself before looking at the answer. To find the derivative, we just take implicit differentiation. So we take the equation and we solve both sides. So the left-hand side on the one hand and the right-hand side on the other hand. We then calculate these derivatives. The derivative of x to the power 3 is 3x squared. For y to the power 3, this is 3 times y squared times y prime, because y depends on x, is then equal to the derivative of 6xy. This is 6y plus 6 times x times y prime according to the multiplication rule. We then group all the terms with y prime. So this is 3y squared y prime minus 6x y prime equal to 6y minus 3x squared, or y prime is 6y minus 3x squared divided by 3y squared minus 6x, which is, if we divide everything by 3, 2y minus x squared over y squared minus 2x. And then as a final example, find the equation of the tangent line. To the function x squared plus xy plus 2y to the power 3 equal to 4 at the point P minus 2, 1. To find the equation of the tangent, we know that we have to find the slope of the tangent line, and the slope of the tangent line is just the derivative at the point P. So we need to find the derivative of this expression, and since we have again a term x times y, so it's impossible to split it into y equal to something else. So what we will do is we will apply implicit differentiation. So we derive the left hand side again, and we derive the right hand side. Left hand side 2x plus y plus x times y prime plus 6y squared times y prime is equal to the derivative of the right hand side, 0. We group everything with y prime on one side, so it's x times y prime plus 6y squared y prime is equal to minus 2x minus y, or y prime is minus 2x minus y divided by x plus 6y squared. For the slope, we don't need to have the general expression of the derivative, but we need to have the derivative in the point P. So in the point minus 2, 1, we just plug in the value. So this is minus 2 times minus 2 minus 1 divided by minus 2 plus 6 times 1. So it is 4 minus 1, which is 3, divided by minus 2 plus 6, which is 4. So the value of the derivative is 3/4. And then the tangent line in P, this is y minus 1, so y minus the y value in P, equal to the slope, which is 3 over 4 times x minus minus 2, which is x plus 2. Or if we rewrite this, we work it out, this is 3 times x minus 4 times y equal to minus 10.